Hello, this is Mr. Rasmussen with Algebra 2 and Lesson 114. In this particular lesson here, we're looking at locating spots for non-linear inequalities. So we already looked at linear inequalities, and that's where we had two lines and one was either solid and they're either solid or dashed, and we had to find which of the four quadrants that was meaning. So we're back to that, but this time it just gives a nonlinear mean. Here we have a parabola in this first example here. So let's jump into this. First of all, we have in example 1 here. We can see this is in slope-intercept form, and so you can see that that graphs this straight line right here. It's linear. Then this guy over here, you can see the squared in there, and so he graphs a parabola, and so there's our nonlinear part. All right, so if we consider those two graphs, it splits our graph here into 4 different spots. And so I grabbed some colored pencils here to try to show you those spots. First of all, if we look at the linear graph, here this line, we have an above, which includes A and B, and we have a below, which includes C and D. Okay? Then, in conjunction with this parabola here, the parabola has an outside and an inside. Okay? So here's B and D are both on the inside of the parabola, and A and C are both on the outside. However, so using those, we put it into 4 different quadrants. So A quadrant here, I'll put that on here, the green color. The green color is above, A is above the linear line, okay, but, and on the outside, on the outside of and above the parabola. So we got A here, I wanted to show you, there we go, put in a green color. There's our one quadrant, you see that? It's on the outside of the parabola, but it's also above the line. Then we can go on the outside of the parabola and go below our linear line, and I see a red color here. That's over here. See how we're below the linear line? Okay? But we're still on the outside of the parabola. Okay, so that's red. So that's section C. And then B is going to be above our linear line, but inside the parabola. So if I use blue there, see that? There we go. There's my section B. All right, and then D here, I'm use yellow color. Okay, and D here you can see is inside the parabola or below it. Okay, because it's inside and the parabola is open to the down. Okay, but also below the linear line there. Okay, so there's our different spots, and I'll take the extra time to write that in there. So let's put an L for linear and a P for parabola. Okay, L for linear and P for parabola. L for linear and P for parabola. Okay, so let's put some things here. A, notice A is above the linear line, okay, and we can also say, since it's on the outside of the parabola, it's above the parabola because the polar parabola opens down, so any part on the outside of the parabola is going up, okay? If you look at B, B is also above the linear line, but it's below the parabola. Section C is below the linear line, and on the upside, on the outside, or on top of the parabola, because it's, see how the parabola keeps open and down, it's going to keep going this way here. All right, and then the yellow is below our linear line, but also below on the parabola. So you can see our 4 different options there between the two. So that comes to our question is, which, if we look at our graphs here with the inequalities, which of these 4 groups is going to qualify for both. Okay, so let's look at our linear one first. On a linear one, remember, it all has to do where the y is at. Okay, so since the y is greater than where our line is at, that means that it has to be above. So since it has to be above, A and B are above, C and D are not, so immediately C and D are out of the running there. Okay, they are not a part of this guy here, the linear. Then we're going to look over here, and once again we look at where the y is at, and the y is greater than this thing, so that means greater than, it means above, and so that would exclude, right, which one is below? The B is below for the parabola, the A is above, so it excludes that one, and A is our answer. Quadrant or section A is the part that satisfies both of these inequalities. Okay, hopefully that made sense there as I put the colors in to show you the spots, but then also put in the arrows to show above and eliminated them as we did. Okay, let's look at the second example here. All right, the second example here. All right, we've got our linear equation here, and that graph is not equal to, so it's got a dashed line coming through there, as you see in your book. And then we've got our parabola once again over here, and it opens up. Okay, so let's put some colors in here. I've got the green one, so we'll make A green. Where's A? A, you can see, is above the line, and inside the parabola. So here's A, okay, above and in. Let's use B, we'll make blue. Okay, so B is above my linear line, but outside or below the parabola. There we go, and B also includes this part right here. Okay, see all this section for B. Okay, for C, I already used green. C, let's use yellow here. C, we're going to use yellow. Yellow is below my linear line, but still inside the parabola. We can see here. Okay, and then that leaves me D. D is below my linear line, but outside the parabola or below the parabola. Alright, so there is D, all this down here. Alright, so we see our three spots there. Let's label some things. L, P, L, P, L, and P. Okay, so A, we notice A and B are both above my linear line, and then C and D are both below my linear line. Okay? Then for parabola, A and C are both above. So A is above, C is above. See that? Because it's opening to the top there. So this part's above, this part's below, or outside, inside. Okay, and then that gives me as the D and the B areas are below the parabola because you're on the outside. Since it's opening up, it's going to keep opening this way. So think of it as a V, and the A and the C are on the inside, so they're up, and the B and the D are on the below, or on the outside of the V, if you think of it that way, or the smile. Okay, now to our question. It has to be the y. The y is less than our equation on the linear, so if it's less than, it's below. So that excludes A and B, right? A and B are out because they're above, and this here, the y is less than, so it's below. Then we come over here, and where's my y? My y is right here, and it's greater than my equation, so greater means above. So what's the only spot that is above? Well, D is below my parabola, C is above, right? C is above, D is below, so it has to be above, so C is my answer, D gets rolled out. Okay, so C is the section that qualifies for this. Then as you notice in the book there, they actually run this through a test. They take a point inside of section C. You can see x is -2, y is +1. They take that and then they put that back into our equations to see if they're true, just as a test. So let's do that. If we put the y value in, that's 1 is, oh, I got an equal sign in there. Look at that. That's kind of funny. That's not supposed to be there because we have an inequality. So 1 is anything less than negative, and then we put in parentheses negative 2 for my x value plus 1. All right, let's solve this here. Negative times negative is a positive, so 2 plus 1 is 1 less than 3. Yes, it is. So that is true there. And then they also test the other equation. So we've got 1 is anything greater than or equal to, parentheses, negative 2 squared plus 4, negative 2 plus 2. All right, so this one here, negative 2 times negative 2 is a 4. This one here is a negative 8 plus 2. All right, so we have 4 minus 8 plus 2. That looks like it works out to be negative 2. Is 1 greater or equal to negative 2? Well, it's definitely greater than, and so that is also a true statement, and it's just proving that we have selected the correct section here as our answer. If we'd have picked a point somewhere up here in A, perhaps if we were to pick, let's say negative 2 on the x value and 5 on the y value and put it in there, then it should prove a statement that is false. Okay, let's look at example 3 here. Example 3. Hopefully the colors made sense for you. All right, we have this line here which graphs a circle, and then this one over here which graphs a linear line. So let's put, once again, L's for linear and then C's for circle. L, and C. Okay, and then I'm going to box these up because these are just my quadrants. And you know what? Let's put the colors in there just because colors are fun. Okay, we got section A. Here's section A. We got section B. Here's section B inside here. Oh, I didn't color coordinate it. There we go. There we go. All right. Section C's in here. This one's perhaps a little bit easier to see. The sections are pretty clear. And here's section D. All right. There, I've color-coded it. Okay, so let's put in some labels here. Section A and B, right, are both above the linear line, and you can see C and D are both below this linear line. And then on a circle, we have an inside and an outside, okay? So an inside is below and outside is above or greater. Think of it as up going greater and inside is less than or restricted or less than. Okay, so for my circle here, A, we're going to say A is on the outside or above or greater. Okay, put a G for greater. B is going to be on the inside or less than, put an L for less than. C is on the inside, less than. D is going to be, for the circle, on the outside or greater than. Okay, so let's look at our linear line first, a little easier. My y is over here, and so my y is greater than the rest of the equation x, so greater than, it means above. So that means that it excludes answers C and D. Those are out. Okay, it's above. So is it on the outside of the circle or on the inside of the circle is our last question. Now this one's a little tricky because the y is on the same side as the x, but it all has to do where the y is. And the y is less than, the 16, the value given. And so, since it's less than, it's going to be restricted or on the inside, not the outside, not above. So it's not A, it's going to be answer B. Answer B, as this guy here, y is less than or smaller. Think inside is smaller, outside is greater. Okay, and then you can see in your book there, once again, they take the values, they pick this point right here, which is x negative 2 and y positive 2, and they put it into both these equations and show that it is a true statement. Let's try something a little different here, though. Let's pick negative 2x and 6 on the y, one that should produce a false statement, and put it in there and just see what happens. Okay, so if we put it into that one, that's pretty easy. 6 is anything greater than or equal to negative 2. That's actually a true statement. right? Why is that a true statement? Well, because y is above x and a is also above x. So for this one, it works because a or b. If we were to put anything from down here in c or d, that would make that one a false statement. Let's try it. Let's pick a point right here. We've got 3 on the x and -2. So if we put those in, -2 is greater or equal to 3. No, that's false. Okay, then if we take this here, it should be false if we put it into this statement. Let's try it. We've got -2 squared plus 6 squared is less than or equal to 16. So this one here is a 4. 6 squared is a 36. Add those together, we get 40 is less than 16. No, not going to work. The only thing that's going to work is any of this section here inside of B. Okay, I hope that's pretty clear. This is a very simple lesson. I am definitely exaggerating it with my colors and my explanation there. Here's the practice problem. Let's go through and just simply answer this one. We've got our circle here, and then we've got our line here. So notice our line says, y is anything greater than? Okay, so it means above. So automatically C and D are out. This has to be A and B. A and B are both above. Okay, and then one of these, A or B, is going to get excluded. Over here, y is greater than 9, greater, larger, outside. Between A and B, which one's outside? Answer is A is on the outside, B is on the inside. So our answer for the practice problem is A. And as I did it there, it is really just that simple of picking which quadrant as eliminated, which quadrant the answer is in. And you could do it the other way. If you were to look at this one here first, you can see it's on the outside, so that would eliminate answer B and C, and the answer would be either A or D. And then you can come over here and see that D is below and it needs to be above, so answer A. Okay, pretty straightforward like that. The circles are definitely easier than perhaps a parabola is, just on to think about it. But hopefully that makes sense. Okay, feel free to text me if you need some direction on that. Have a great day.